He could, then I could do this one and then my other one, yeah. Well, it depends what Nick wants to do. No, I think it'd work best if I did this now, because it's very short, it's 5 minutes.
Alright, yeah. Then what are you going to talk about after that?
Then we're going to stop, and then Nick will talk, and then I'm going to come back to
But you haven't got any slides to
I haven't got any slides for the last one.
No.
So, yeah, this is it, well, they're already. Full screen?
Get some questions and discussion.
That's it, fantastic. All right. Thank you very much. Continuing.
It's on. It's okay.
We're on, yes. Continuing. This is to bring us more into the dynamics, Earth dynamics stuff. Right. As far as I'm concerned, in meteorology, we need to go for this. There's 3 big questions which are basically not addressed properly by standard meteorology. Are the quasi-equilibrium assumptions valid? Because that's what standard meteorology runs on, as does most physics and thermodynamics. Do temperature changes require heat inputs? Or do heat inputs always lead to temperature changes? That type of thing. Third one, what changes the jet stream? Okay. Right, so let's move on quickly. Right. Are quasi-equilibrium assumptions valid? So, you know, standard meteorology says, oh, heat in, heat out, everything's equal. Well, actually, during a mini ice age, the whole world is cooling. There's great amounts of heat have been subtracted. Going into a real ice age, there's vast amounts of heat comes out. There's no way this is equilibrium. There's no way, completely no way. So Q dot equals 0 is a nonsense. It might happen some of the time, but, you know, in important times, that is untrue. And the important times are, dare I say it, the important times. So the rate of change of heat content, you see it might be leading to changes of state. But one very important thing, and this is happening now, would you get these wild jet stream, bigger area to the north, what happens is the area of extent of snow in the winter gets bigger. And as I said before, this year the area of extent of snow is the most extent has been the highest for 50 years. That means there's extra reflectivity. So there's a feedback mechanism then which means less heat input from the sky. So that is going to make cooling. And next year it's going to be more. So you can see, once you get into a mini ice age, you can gallop down quickly, as that graph showed before. And we are at the knee. Okay. We went into the day-night errors, which they've been ignoring. So that is enough on that one. Do heat temperatures require... well, no, they don't, because I said, you see, the area, if the area of cold, the jet stream moves, makes the area that's colder bigger, well, it is colder then. If you measure a surface average, it's colder. So, like, if you get a table and put a block of some snow on it, that's a certain average temperature, spread the snow out, it's a lower average temperature, but there's no heat change, nothing's happened, we've just changed the surface. And you see, measures of surface temperature is what meteorology relies on. It's not a measure of total heat or anything, it's a measure of surface temperature, which is important for farmers. Right, oh, this is a bit of science, so sometime I'll give a fuller presentation on all this stuff, but the reason why the jet stream gets longer is something to do with the transfer of rotation. I don't know if... Is anybody here familiar with what all this means?
No.
They can't see.
Oh, put the globe down again. Yeah, well, the surface integral of curl of V is the scalar line integral of V dot dl, which is the speed and the length. This means the average speed of the jet stream and the total length. So that gets bigger when this rotation from the sun gets forced in more. So that's why the jet stream gets longer. We'll come to that some other day in full. Yeah, well, we've done that picture already. This is just to show you again, or this is important, that this is a Fourier plot. Anyone here familiar with Fourier plots? Yes, 1, 2, 3. That's good. Okay. This is just a little graph to show you what are the big signals in solar activity. The main signal of geomagnetic activity, which is the magnetic field of the sun wobbling around due to the solar wind hitting it, that gets more every 11 years, as do the sunspots. However, the world temperatures do not follow that. They follow a 22-year thing, which is the connectivity, the magnetic connectivity between the magnetic field of the sun and the Earth. and that changes direction, you see, the sun changes direction, so it has a good connection in odd cycles and a bad connection in even cycles. And then with lower solar activity, it's a generally bad connection, but it's badder when we're in even cycle, which is now. Right. What changes the heat? Well, there's lots of stuff. There's internal causes. See, volcanoes now are increasing. The underside of the West Antarctic there's masses of volcanoes. There's actually thousands of undersea volcanoes, ignored by standard meteorology. But these actually get more during mini ice ages, which is interesting. The Sun-Earth link, though, is direct. It's not cosmic rays, because if it was cosmic rays, we'd have an 11-year cycle of temperatures. We do not. We have a 22-year cycle. The electric universe idea, though, is, you know, it says more and more about magnetic links. And I mentioned one of those, just showed you that one earlier. We're going to go past this. That's about how solar wind changes the rotation of the Earth by very tiny bits, which gives you northerly currents on the European coast. We've seen that diagram before, we've seen that one before. This one we've seen before, but okay, there's an extra bit of information on this one. There's some recent analyses which show there's a 14-year cycle in a lot of currents. 14 years. And what is that about? If you analyse solar data, there is a 14-year cycle in solar activity near the the equator of the sun. So there's a solar signal directly separate from the 22-year signal, which is shown in ocean currents, which is very important, because as I said, the transport by ocean currents is going to be more than by air. And here, well, what's it all about? Well, okay, this tells you what it's all about, and I'm sure we'll agree with this. You see, the sea is a weak conductor. So there's going to be electric currents in it, and so on. But we didn't go into that, but just to say you can, you know, work out how deep the effect of changing magnetic fields will be in the ocean. And it is pretty deep. I can't read the figure there, but it's like kilometres, right? So there are things going on which will affect the oceans directly, and they're electrical. They're electrical. And we are probably getting to the end of this. I think that may be, no, but we've done that one before. Sorry, we didn't do that. We just passed that. So, what causes weather extremes? Jet stream changes. What moves the jet stream? It's changes in solar activity. And the biggest link is, well, the only link is magnetic and particle, and probably directly to the oceans. And these things are predictable. And if governments cared, they would fund me by millions of pounds, but I'm looking forward to that.
Would you take money from the Tories, Piers?
Will I take money from the Tories? Well, I'll take money from any government, yes. Yeah. Well, I'll have to think about that. No, don't answer that question. Sorry, something in my ear saying, Piers, don't answer that question. Yeah, well, you know, I do have to be careful sometimes. I don't know where this ends, actually. Oh, it almost ends there. Well, yeah, just to say, this is reality. Well, my view of reality. There is more to it, I'm sure. But solar activity drives the solar wind. This is modulated by the moon, which we didn't go into this time, but it gives a 60-year cycle with the magnetic effects of the sun and the moon. That modulates the jet stream, which gives you weather. And in parallel, you have extravolcanism and earthquakes under certain circumstances which affect the weather, and altogether that surface temperature gives you life, the gas of life, which is CO2. The effect is not the CO2 driving the weather and driving the jet stream and driving the meteosphere and driving solar activity. If you drive your car fast back to Bath, it will not cause a solar flare. Do not worry, and we will end there. On with objectively.
Bravo, well done, Piers. Thank you very much, Piers. That's great. One of the things I happened to notice they were talking about the genocide that happened in South America. 60 million people who died during effectively during the Maunder Minimum.
Yeah.
And they tried to say that the Maunder Minimum was caused by the fact that all these people who died in South America were no longer planting crops and all the rest of it. All the trees grew up and took all the CO2 out of the atmosphere, and that's I read that on the BBC.
Except that's an effect after a cause,
You
hasn't
couldn't
it?
make it up, could you?
Shocking.
They're so desperate not to accept the reality of something like the Maunder Minimum. It's extraordinary. We'll have like a 2-second break, if you're patient, and then we'll have
Well, we don't need
Nick.
one.
Nick, I mean,
Nick's got
unless
to
people want to
My bum hurts.
Exactly. There's only so much sitting
So have a big
down.
break, then you have Nick, and then you have me again.
Yeah,
for
and then
sure.
I promise you that it's supper. Supper really will be on time. Yeah. See you back.